This is the video lesson for number 10-5. In the last lesson, we learned how to find the standard deviation and that it is a measure of variability. Today, we are going to learn what the standard deviation actually means. We need to remember the Greek letter mu represents the mean. Okay, a normal distribution. When we find the standard deviation, we are finding the standard deviation of data that has a normal distribution, that it's symmetric around the center. That means that about 50% of the data is below the mean and about 50% of the data is above the mean. And this means that the mean, median, mode are approximately all the same number. Okay, we're going to be looking at here just a second, but we're going to talk about all this kind of in general. So let's go ahead and look here at our graph below. And let's talk about what each of these mean. Okay, on our graph, the center line right there represents the mean of the data. So I'm going to go ahead and have you draw a line from that bullet up here to show that this right here is the mean. And this is mu. So the center line right there represents the mean of the data. Okay, we also need to recognize that 68% of the data is within one standard deviation. And we represent that by saying mu plus or minus sigma. And remember, sigma represents the standard deviation. So that is right here. So this is one standard deviation to the left, and this is one standard deviation to the right. And to find those, you take the mean and you subtract sigma to find this one standard deviation on the left, and on the right, you take the mean and you add sigma to it, the standard deviation. Okay? And we need to remember that the middle is the mean, and that is represented by mu. Okay, then we have two standard deviations. That is represented by mu plus 2 sigma and mu minus 2 sigma. That's 95% of the data is within two standard deviations. Okay, so this is our second standard deviation on the left. This is 2 standard deviation, and then on the right, this is 2 standard deviations on that side. Then our last one is going to be 3 standard deviations. 99.7% of the data is within 3 standard deviations, and we represent that, we find that by mu plus 3 sigma and mu minus 3 sigma. So right here, this one is 3 standard deviations. Okay, right there. Okay, I'm going to give you an example to help you understand what this means. Before I do that, I'm going to go ahead and mark down, though, our percents. So remember that between the first standard deviations, that is 68% of our data. Okay, and then within 2 standard deviations, that is 95% of our data. And then within 3 standard deviations, that is 99.7% of the data. Okay, so we need to remember that. Okay, we're going to come up with a situation, and we are going to say that the mean, let me go ahead and just write it up here. The mean, which is represented by mu, equals 20, and that our standard deviation, which is represented by sigma, equals 3. This is going to help us understand how this works a little bit better. Okay, so I know my mean is 20, so I'm going to come down here and say, well, I know my mean is 20. Okay, so I want to know where is one standard deviation to the right and one standard deviation to the left. Well, to find 1 standard deviation to the right, I do the mean, which is 20, plus a standard deviation, which is 3. So that tells me that 1 standard deviation to the right is 23. Then, to the left, I take the mean, which is 20, minus the standard deviation, which is 3, and I get 17. Okay? So I just found out now that 68% of the data is between the two numbers 17 and 23. Now this is different than a box and whisker plot. Remember the box and whisker plot was broken up into quarters and of 25%. This one's broken up a little bit different, but it's still talking about how the data is spread out. So we know that 68% of the data is between 17 and 23. Okay, now we want to find our second deviations. Sorry, our second standard deviations. So I'm going to take the mean plus 2 times sigma. Put that above here. So I get 20 plus 6, so that's 26. Then over here, I have the mean minus 2 times sigma, so that is 14. So now I know that 14% of the data is between 14 and 26. Okay, and then our last one, we're going to find our third standard deviations. So to do that, I have mu, which is 20, plus 3 times 3 gives me 29. And over here, I have mu, which is 20, minus 3 times 3, which is 11. So now I know that 99.7% of the data is between 11 and 29. So almost all the data, with the exception of a few, is going to be between 11 and 29. Okay, so it's just the spread. How are we spreading things out? Okay, also if you'll notice down here at the bottom, we have a test next time. So you need to make sure you study 10.1, 10.2, 10.3, 10.4, and 10.5. Also make sure you have the notes for those 5 lessons. We will have a notes test on this. On number 1, we're given that the mean is 18 and the standard deviation is 4.5. Let's go ahead and find our first, second, and third standard deviations on our graph here. So up here we have our mean, which is 18. Here's 1 standard deviation, 2 standard deviations, 3 standard deviations here on the right. Left, 1 standard deviation, 2 standard deviations, and 3 standard deviations. This obviously is not to scale. It's just kind of help me visualize what's going on here. Okay, to find my first standard deviation, remember that is mu, so 18 plus sigma, which is 4.5, and that gives me 22.5. Over here on the left-hand side, it's 18 minus 4.5, which gives me 13.5. And I can now see that 68% of my data is between 13.5 and 22.5. So I can put that in over here, that it's between 13.5 and 22.5. Okay, now we're going to figure out 2 standard deviations. So that's 18 plus 2 times 4.5. So it's 18 plus 9, which is going to be 27. And this side is going to be 18 minus 2 times 4.5. So that's 18 minus 9, which is 9. And now we can see that 95% of our data is between 9 and 27. Okay, our last one, we're looking at the third standard deviations. So we have that this is 18 plus 3 times 4.5, which is going to be 31.5. Over here, I have 18 minus 3 times 4.5, which is going to give me 4.5. So I can see that 99.7% of my data is between 4.5 and 31.5. Okay, on number 2, we're going backwards. I'm telling you that 95% of the students, that's an important piece of information right there, is between 36 kilograms and 80 kilograms. Assuming this data is normally distributed, find the mean and standard deviation. So the mean is going to be the center of 36 and 80. So if I was to draw this out, let's look at our bell curve here. So this is the mean, and I have 1 standard deviation, 2 standard deviations, and 3 standard deviations. And I know that this one is 68%, and this is 95%, and this is 99.7%. So I know that there's my 95% right there, and up here I have 95%. So I know that the standard deviations, the second one on both sides, this one is 36, and this one is going to be 80. And the mean is right in the middle of those two. So to find the middle of those two, I'm going to add them together. So I have 36 plus 80 divided by 2 is going to be 58. So I know my mean is 58 now. Okay, now I need to figure out what my standard deviation is. So I'm going to look at how far is the mean to there, and how far is it from here to here. Well, I have 58 minus 36, that is 22, and 58 plus what? So 80 minus 58 is also 22. So 2 standard deviations away is 22 spaces. So one standard deviation away is going to be just one place. So because 2 standard deviations is 22, so I'm going to divide both these by 2. So I get that 1 standard deviation is 11 away. Okay, so if I go back up here, I can say that 95% of the data in a normal curve is within 2 standard deviations, and the difference between 80 and the mean is 22. So divide your answer C by your answer B. So I have 22 divided by 2, which is going to give me 11. So my answer is that the mean, I didn't write that over here either, is 58. The standard deviation is 11. Those would be my 2 answers. Okay, and we kind of outlined it here a little bit more. We're going to do this again now on number 3. On number 3, it tells us that a mill cuts trees into framing studs. 99.7% of the widths are between, this is going to be 1.992 inches and 2.022 inches. And remember that we said this is 99%, 99.7%. So that is 3 standard deviations. So I'm going to go ahead and create my bell curve. mu. So 1, 2, 3, 1, 2, 3. And I know that since it's 3 standard deviations away, this is going to be 1.992, and this is 2.022. So the first thing I want to do is find my mean. So the way I do that is I add these two together and then divide by 2. So I have 2.022 plus 1.992, all divided by 2. And if I put that in my calculator, I'm going to get 2.007. So my mean is 2.007. Okay, now I need to find how far apart these are. So if I do 2.007 minus 1.992, I get 0.015. And if I do 2.022 minus 2.007, I get 0.015. So I have 0.015. That is 3 standard deviations away. So I'm going to divide by 3 to find out how far 1 is. And I get 0.005. So that's my standard deviation. And my mean is 2.007. Those are my two answers. Okay, now we're going to try this again, and I'm not going to draw it out this time. So let's see if we can figure this out. Okay, so 95% of the data is between 2 and 12. Assuming the data is normally distributed, find the mean and standard deviation. So I know that the mean is halfway between here. So my mean is going to be 2 plus 12 divided by 2, which is going to be 7. So there's my mean. If it's 95%, I know that's 2 standard deviations away. So this is 2 standard deviations. So I know that 2 is 5 away from 7 and 12 is 5 away from 7. So they're both 5 away. And if I was to sketch that out really quickly, you can see that. So here's my mean, which we know is 7. Then I have 1, 2, 3 standard deviations. And 95% is right here, so I know this is 2 and this is 12. So I can see that this one is 5 away and this one is 5 away. So to find my standard deviation, I'm going to take 5 and divide it by 2, and I get 2.5. Okay, we're going to try number 5 now. This one is 99.7% of the data, and that is between 8 and 16. So to find the mean, I need to find the middle of those two numbers. So 8 plus 16 is 24, divided by 2 gives us 12. So the mean is 12. Okay, to find my standard deviation, how far is 8 from 12? That's 4 places. How far is 16 from 12? That's 4 places. So 4 divided by, and this is 3 standard deviations, so I'm going to divide by 3, which I can either leave as just 4/3 or 1.3 repeating. Okay, we're going to talk about how to compare data. So if both sets of data are symmetrical, we're going to compare the means and the standard deviation. So depending on the spread of our data depends on what we're going to compare. If one or both sets are not symmetrical, we're going to compare the medians and the IQRs. So we're looking here, and this is symmetrical because the median is halfway between the first and third quartiles. So if I was to compare the data, I would compare the means and standard deviations. But if it's not symmetrical, I'm going to compare the medians and the IQRs. Okay, so the first thing we're going to do is we're going to make a box and whisker plot for number 6. So the first thing I want to do is I want to find the middle here. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's first of all talk about what the data is that you've been given here. First of all, this is the area of the Midwest states in thousands. So we have Indiana, Ohio, Iowa, Illinois, Wisconsin, Missouri, North Dakota, South Dakota, Nebraska, Kansas, Minnesota, and Michigan. So those are the areas of each one of those states. And we're going to do a box and whisker plot for them. So we saw there was 12. So our median is going to be right between Missouri and North Dakota. This is our median. And I do 69.7 plus 70.7. Add this together, divide by 2. And I'm going to get 70.2. That's my median. Okay, now we're going to find the median of this half of the data. So there's 6 on this side, so it's going to be right between Iowa and Illinois. So 56.3 plus 57.9, add those two together and divide by 2. And you're going to get 57.1. That's my Q1. This is my min. This is my max. Okay, now we want to find the median of the right side of the data. So right between Nebraska and Kansas. That's going to be my Q3. So we're going to add 77.4 together plus 82.3. Add those two together, divide by 2, and you get 79.9. Okay, we're going to go ahead and plot that down here. So my min is 36.4. So this is 35, so it's going to be about right there. Then 57.1, right there. 70.2, so about right there. And then 79.9, that's really close to 80, almost 80. Let's go ahead and make our box. And then my max is 96.7. Okay, so this is the box and whisker for the Midwestern states. Okay. Now we're going to go ahead and do the same thing for the Western states. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the middle is 1, 2, 3, 4, 5. So Colorado is our median. And then we'll go ahead and find the median on the right-hand side. That's going to be New Mexico. So that'll be our Q3. This will be our max. Then on the right-hand side, Utah. Be right there. That's going to be our Q1. And Washington will be our min. Oh, I just realized we had an error here. Nevada has a V. It's not Nebraska, that's Nevada. Okay. All right, just a little technicality there. So 71.3, about right there. Utah, about 85, right in the middle. Colorado, 104, 121.6. And our max is 163.7. Okay, so this one is just the western states. Okay, are both sets symmetrical? Well, if I look over here, this is definitely not in the middle, and 50% of the data, and this 50% does not look symmetrical. Same thing over here. This is much wider than this one. So I'm going to go with no. No, both sets are not symmetrical. So if they're both not symmetrical, what am I going to compare? Well, it says if one or both sets are not symmetrical, I'm going to compare the medians and the IQRs. So I'm going to compare the medians and the IQRs. So now we're going to compare them. So I need to figure out which each one of them are. First of all, I already know the medians because I found that to do my box and whisker plot there. And we can see that the median of Colorado is 104.1 versus the median of 70.2. Okay, so since 104.1 is greater than 70.2, on average, the western states are larger than the Midwestern states. Okay, now we're going to compare the IQRs. So we need to find the IQRs for each one. So if I come up here, my IQR is Q3 minus Q1. So I'm going to do 79.9 minus 57.1. So 79.9 minus 57.1, and that gives me 22.8. My IQR for the western states, that's going to be 121.6 minus 84.9. So my IQR for them is 36.7. Okay, now the IQR is talking about how spread out everything is. Okay, so since 36.7 is greater than 22.8, the size of the western states vary more than the Midwestern states. Okay, our last last page here. Okay, Mrs. Johnson gave a test to 24 students in each of her math classes. The results are shown below. And we're going to go ahead and create a dot plot for each class. Okay, so let's go ahead and we are going to look here, the first one. Okay, so we have 123, we have 124, 2 25s and 3 26s, 3 27s, 4 28s, 3 29s, 3 30s, 2 31s, a 32, and a 33. Okay, now we're going to go ahead and do the A2 class. We have a 25, 2 26s, and 4 27s. And there are 1, 2, 3, 4, 5, 6, 7, 8 28s. Five 29s, 2 30s, and a 31. Okay, are both data sets symmetrical? If I was to go ahead and outline those, definitely they're symmetrical. Okay, so we're going to write yes. So if it's a yes, let's go back and look at the directions before, and it said that if both sets are symmetrical, we're going to compare the means and the standard deviations. So we're going to compare the means and the standard deviations. So we want to compare the two data sets using the correct measure of central tendency and the correct measure of variability. Now, fortunately for us, we can just go ahead and put all that data in our calculator, and it'll calculate both the means and the standard deviations. Let's go ahead and do that. So we're going to get our calculator. We need to make sure it's in stat mode. So we're going to go second stat and hit enter, and now our stat button shows up. So now we're going to put in our data. So I have 123. I have 124. Now in 25, I have 2 of those. 26, I have 3 of those. 27, I have 3 of those. Let's set this down so it's easier. Okay, 28, I have 4 of those. 29, I have 3. 30, I have 3. 31, I have 2. And 32, I just have 1. And 33, I just have 1. Okay, so now we're going to go ahead and calculate our data here. So I'm going to go ahead and the stat bar. And I'm going to go over to my X bar. That's our mean. So I know for this one that my mean is 28. I'm just going to write that up here. And I'm going to go over to the sigma one. So my standard deviation is 2.5. Okay, now we want to go ahead and do that for this one. I want to clear my data, so I'm going to go second, stat, arrow over twice, and hit clear data. So I don't have to worry about putting that anymore. Now I'm going to hit the data button. Okay, so now I have 125. I have 2 26s. 27, I have 4 of those. 28, I have 8 of those. 29, I have 5 of those. 30, I have 2 of those, and then I just have 131. Okay, we're going to go ahead and hit stat bar again to calculate that data. And I arrow over to my X bar, and I get that my mean is 28. So I'm going to write that down. And then I'm going to go arrow over twice. And 1.4 is my standard deviation. Okay, so now we want to compare those. So if I'm looking at the means, so since 28 equals 28, on average, A1 and A2 scored the same. Okay, now we're going to compare the standard deviations. So since 2.5 is greater than 1.4, A1 scores varied more than A2. So the standard deviation, what it did was it told me how spread out the scores were. So you can see that A1, those scores are much more varied. They're more spread out. They have a higher standard deviation than this one. They both have the same mean, but these scores are much more clustered together than these. That's why it has a lower standard deviation. Okay, our last one, number 14. So if the mean weight of a baby chick is 22 grams and the standard deviation is 2.5 grams, then 68% of the baby chicks are between these two and 95% are between these two. So let's go ahead and just do a quick little sketch here of our bell curve. So I know my mean is 22. I have 1 standard deviation and 2 standard deviations. That's all I'm doing because I have 68%, which is the 1 standard deviation, and 95%, which is 2 standard deviations. Okay, and my standard deviation is 2.5. So I'm going to add 22 plus 2.5, and that's going to give me this number, which is 24.5. This one is going to be 22 minus 2.5, which is going to be 19.5. So 68% of my baby chicks are between 19.5 and 24.5. Then we're going to add 2.5 again over here. So I have 22 plus 2 times 2.5, which is going to give me 27. And this one is going to be 22 minus 2 times 2.5, which is going to be 17. So 95% of my baby chicks are between 17 and 27. Just a reminder, you do have a test next time.